So first we have to use a substitution t equals tan theta. So I'll just write that down. So we're using t equals tan theta, and therefore we know that dx is sec squared theta to theta. Alright, that's the first one we have to use. So let's have a look at the integral then. The integral will be, so it was 0 to 1 for x's. So x equals 0 when we have tan 0. And x equals 1 when we have tan pi on 4. So we're going from 0 to pi on 4 now. We have log of 1 plus x, and x is tan theta, all over 1 plus x squared is tan squared theta, and dx is sec squared theta to theta. All right, we know that 1 plus tan squared is sec squared, so those cancel there. So we just have the integral 0 to pi on 4 of log of 1 plus tan theta to theta. All right, and that's what we had to show, so that's done. All right, next use a substitution u equals pi on 4. I'll do it in another color so you can see. So u equals pi on 4 minus theta. All right, so now we're going to look at the integral again. Let's just do this. So du equals minus to theta. So minus theta minus to theta. All right, so the integral here would equal, so we're using, oops, something on the screen there. We're using our above here. So instead of 0 to pi on 4, so when the angle is 0, so if I put 0 in here, I get pi on 4. When I put pi on 4, I get pi on 4 minus pi on 4, so I get 0. Right, then I have log of, and here I've got 1 plus tan. Now theta, if I make theta the subject, I've got pi on 4 minus u. Alright, so I've got that. 1 plus that, and then I've got to theta, which is minus du. All right, I can take care of that minus by just switching the limits so that that minus has been taken care of. And then if I make, did I forget? Nope, I didn't. Okay, good. So we know how to expand. So we've got 1 plus. So think of tan A minus B. So that's tan A minus tan B all over 1 plus tan A times tan B. We know that tan A, tan B there. There we go. So we've got all of that du. All right, just moving up a little bit here. Okay, so we know that tan pi on 4 is 1, so it's just 1 lots of tan u there. So you can see also this 1 at the front, if I make a common denominator, this is going to be 1 plus tan u. If my denominator is 1 plus tan u. So then I'm going to have plus 1 minus tan u if I join them all up. And you can see there the tan u's will cancel in the numerator. So I'm just going to get 2 over 1 plus tan u. So this becomes log of, so 0 pi on 4 log of 2 over 1 plus tan u du. And remember, u is just a letter that we can exchange for any letter, so any variable really. So here's our log. We can just make it 1 plus tan theta to theta, and it's exactly the same thing. All right, so there we've shown our second one. So this one is, excuse me, shown. So it says finally deduce. All right, so I'll do it up here. So if we know those two things, then it's nice and easy to deduce this last thing. So the integral, if I put it in this in B, we're doing 0 to pi on 4 log. Now I can use log laws here, so I'll just put log 2 minus 0 to pi on 4 log 1 plus tan theta. D theta. Oh, they're both d thetas, so I should put a d theta here. All right, now of course log 2 is just a constant. So I've got log 2 out the front, and it's just 1 d theta, which becomes theta between 0 and pi on 4. And you'll note that this part comes straight from here, so it is equal to the integral, which is nice. So now if I put that on the side, I've got 2 lots of the integral equals, and this will be pi on 4 minus 0, so pi on 4 log 2, so pi on 4 log 2, and if I divide everything by 2, that integral will be pi on 8 log 2, which is what we're trying to deduce. All right, so hopefully that helps.